Now we start with the second chapter, Pythagoras theorem. Okay, this is a very easy chapter. This chapter carries 7 marks. Now see here also children, you can score full 7 marks in this chapter. Now here, what is a Pythagoras theorem? So you know what is Pythagoras. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. That is what Pythagoras theorem is. Here also there are some theorems which you should remember and by heart it. These theorems will again come in the board examination. Okay. Now remember, this is also in 9th standard you have done, connected to that 9th standard also you have done 30, 60, 90 triangle theorem. Now that, you know, children, you should practice it. So you can get that theorem from your friend, textbook from the from your friend, and then you just go through 30, 60, 90 triangle. Similarly, 45, 45, 90 triangle theorem. Now in this, the main theorem, if you see on page number 33, is similarity and a right angle triangle. Okay, that is what it is. And here you have to prove that the 3 triangles are similar. Is that clear? Now you see what they have given, you know, children. They have given a triangle, right angle triangle they have given. Now in that there is one perpendicular drawn. Okay. Now what do you see here? This is triangle ABC and this is T. Now can you tell me how many triangles can you see in this? Yes, many times children they tell me only 2 triangles. Okay, that is this one and this one. No, there are 3 triangles. One is the bigger one. Okay, that is ABC. I will draw like this. Okay, bigger triangle ABC. Then you are having another small triangle. That is this one. So this is your ABC. Okay, which is B is 90 and this is D is 90. And you are having this one ABD, and next you are having triangle, this one BDC. Okay, is that clear? Now it's very simple. Okay, now what you have to prove is, in this you have to prove that triangle ABC is similar to triangle ABC, similar to triangle ADB, and similar to triangle BDC. Now it's very simple. See here, if I take triangle ABC, okay, triangle ABC and triangle, okay, what will I take? I'll take triangle ADB. Now why I have taken ADB? Now see here how to take this. That is also very important. Now here you see angle A in this triangle, angle A, and in this triangle, angle A, they are congruent. Next is angle B and angle D, they are congruent. So you have studied the properties of similarity. In that, when do you say 2 triangles are similar? By which test you say? You say either by AAA, triple A test, or double A test. Is that clear? Or you are having SAS test. Is that clear? Or SSS. This is how you prove that the 2 triangles are similar. Now in this case, if you see, angle A congruent to angle A and angle B is congruent to D. So these 2 triangles are similar. Is that clear? Understood, children? That is how it is. Now again what I do now, I take triangle ABC similar to triangle BDC. Remember, I am taking triangle ABC. Again I will take triangle ABC similar to triangle now A sorry BDC. Okay, here also you see, what do you find? In this, C is congruent. Now see here, C I will take like this symbol, C is congruent to C. Is that clear? And in this also B is congruent to D. Now remember, your name, whatever you take, it should be 1-to-1 corresponding. Okay, so here you see C congruent to C and B congruent to D, and then A and B. Is that clear? Sorry. Now see here children, what we have got, triangle ABC is similar to triangle ADB, and also triangle ABC is similar to triangle BDC. So what do you conclude? That triangle ABC, okay, is similar to triangle ADB and similar to triangle BDC. This is what you get. What do you call this property? Transitivity, which you have studied in 9th standard, and even in similarity you have studied this transitivity, reflexivity. Have you studied? That is how it is. Okay, now I got this one. The first part is proved. Now the second part, what they have given, no, in the textbook you see theorem of geometric mean. Now theorem of geometric mean, no, you can get it from here only. Now purposely what they have given, you know, they have changed the name of the triangle. They have made it to PQR, and they have taken QS as the perpendicular to side PR. Now what you do, no, in the examination, if they ask you prove theorem of geometric mean, you solve till here, okay, come up till here, which is very easy. As I told you, suppose this is triangle 1, okay, this is 2. You prove that these two 1, 2, 3 are similar. Is that clear? Now what do you want to prove? In this, if I take, now here you see in the textbook what they have told, prove QS square is equal to PS into SR. Okay, what? Prove QS square is equal to PS into SR. Now in this triangle, if I take, what should I get? I will get prove BD square, okay, is equal to BD, that is this one, is equal to AD into DC. Understood? This is what I want to prove. Now in the board exam, if they ask you this theorem, no, theorem of geometric mean, you can prove this first theorem, okay, continue with this one. You need not change the name. From here only you can continue. Now you want to prove BD square is equal to AD into DC. Now see here children, there is a technique of solving a word problem. Theorem. Okay, any proof if you see, there is a technique.